Hey everyone, here's our math problem for today. Find the complex roots of x cubed minus x squared equals 100. When we say we are after the complex roots of this polynomial equation, this means that we are after both the real and the imaginary roots of this equation. It could have been easier if we are only after the real solution, because by trial and error, we may be able to guess what's the value of x that can satisfy this equation. But since we are after the complex roots, we need some algebraic skills to be able to find those complex roots. You can pause the video and see if you can solve this math problem. Now, let's solve this problem together. We are solving this in the context of the lesson about factoring and special products. And this was one of the questions sent to us by one of our followers. In order for us to have a quantitative sense of the problem, let's try the cubes of some integers. Let's say if we have 1 cube, that is equal to 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. We are looking for the cube of the number that is close to 100. But since the operation here is minus, we want that cube of a number to be a little more than 100. Because when we subtract this other part, our hope is to get exactly 100. But we do not know if those roots are whole numbers. We are just guessing here. Let's try also the squares of some integers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Notice that from here, we can already find what's the real solution for this cubic polynomial. Because notice that you have here 5 cubed equals 125 and 5 squared equals 25. If you subtract 125 and 25, you will get this 100. So by trial and error, you already know that the answer for x here is 5. But by the fundamental theorem of algebra, we are expecting 3 complex roots here, equivalent to the degree of the polynomial, which is the degree of the term with highest exponent. So what is now the systematic way of solving this cubic polynomial? There are several ways of proceeding after we found that the value of x here is 5. One of those is to use synthetic division to come up with a depressed polynomial, which in this case would be quadratic, and then use quadratic formula. However, in this lesson, we are solving this in the context of factoring and special products. Let's write this first in the standard cubic equation where the right side is equal to 0. Notice now that this 100 can be split into two numbers so that we can form a difference of 2 cubes and difference of 2 squares. If we cube 5, we'll get 125, and if we square 5, we get 25. We can split this minus 100 into minus 125 plus 25. Anyway, the sum of negative 125 and 25 is negative 100. Then let's rearrange the terms. We can group these first two terms together, and we can also group these last two terms together, but we need to be careful because there is a minus sign here. So this is a difference of 2 cubes. This is a difference of 2 squares because this 125 is 5 cubed. This 25 is 5 squared. So this is now what we are going to simplify. We need to recall the identity for the difference of 2 cubes and the difference of 2 squares. So for the difference of 2 cubes, here is the identity, and here is also the formula for difference of 2 squares. In this case, our a cube is x cubed, our b cube is 5 cubed, which means that this a must be x, this b must be 5. So let's do now the substitution. So the difference of 2 cubes becomes this part here, which is a minus b, x minus 5. Then this trinomial is the square of x, which is x squared, plus the product of x and 5. Notice that we have here a plus sign, plus the square of this 5, which is 25. For this difference of 2 squares, this is our pattern. So you have the product of the sum and difference of x and 5. Then we copy the minus sign and equals 0. Let's simplify this part to get 5x. This part is 25. Copy all the rest. So here is now our result. Notice that you have here a minus sign separating these two terms. This is one term and this is also another term. So let's show now that we are grouping this part together, which is this first term, and we also group this together, which is this second term. Then notice now that x minus 5 and x minus 5 are common factors, so we can factor that out. So this is now the common factor. This first term now, divided by x minus 5, we'll be able to divide x minus 5 divided by x minus 5 to get 1. What's left is x squared plus 5x plus 25, which is now this part. This second term, divided by x minus 5, which is the common factor, we can divide x minus 5 divided by x minus 5 to get 1. What's left is x plus 5. And we copy this minus sign, and we copy equals 0 at the right side. So the multiplication symbol now is this part up to here, and inside this parenthesis you have addition. Then we can distribute this minus sign here, and here is the result. We copy x minus 5, copy the x squared, copy the 5x, copy 25, but we have minus x, then distribute to get minus 5, copy the right side equals 0. Then 5x minus x gives us 4x, 25 minus 5 gives us 20, and so this is now the result. We copy x minus 5 and we simplify the second factor. We now have here two factors whose product is 0. So using the zero product property, we can now equate each of these factors to 0. So the first factor equals 0. The second factor equals 0, which means that if we add 5 to both sides of this equation, x is equal to 5. But in this case here, at the second equation, we are going to arrive at an imaginary roots. So let's use the quadratic formula. Here, our a is 1, our b is 4, and our c is 20. So substituting those values for a, b, and c to the quadratic formula, here is the result. Negative b becomes negative 4 plus or minus. The square of 4 is 16 minus 4 times 1 times 20 to get minus 80 all over 2 times 1 or 2. This part here becomes negative. That's why we have an imaginary number. So 16 minus 80 is negative 64, and the square root of negative 64 is 8i. So we now write this as negative 4 plus or minus 8i over 2. Then there's a common factor here of 2 that we can cancel out. So here is now the result. Then dividing 2 by itself, we get 1. So the final answer is x equals negative 2 plus or minus 4i, giving us a total of 3 roots, which is what we are expecting because the highest power here is 3. Now to check, we can substitute these values for x to the given equation. So substituting 5 for x, we have 5 cubed minus 5 squared, and that's 125 minus 25, which is equal to 100, which is correct. Now checking for these complex roots is more tedious, but let's do that. So if x equals negative 2 plus 4i, we substitute that value to x. And the problem of this is we now have the cube of a binomial, which we can expand using the binomial theorem. So applying the binomial theorem of a cube of a binomial, here is the result. So we begin with a cube of negative 2 to get negative 8, plus 3 times the square of negative 2, which is 4, times the second term 4i, plus 3 times the first term, negative 2, times the square of 4i, which is negative 16, plus the cube of 4i, which is negative 64i. How do we arrive at this negative 64i? If we take the cube of 4i, 4 to the third is 64, I to the third is this I cube. But we can rewrite I cube as I squared times I, and by definition, I squared is negative 1, and 64 times negative 1 is negative 64, and we copy the I. That's why we have this negative 64i. Then, for the square binomial, that's easier. We just squared the first term plus twice the product of the first and the second terms plus the square of the second term. Then let's simplify and remove the grouping symbols. So we have this negative 8 here. 3 times 4 is 12 times 4i is 48i. 3 times negative 2 times negative 16 is positive 96. Copy minus 64i. Then in here, 4 minus 16 is negative 12, copy minus 16i. And let's remove the grouping symbol now. So there's no problem here. This is preceded by a plus sign. We just copy up to this part. But this is preceded by a negative sign. We change all the signs of the terms inside the parentheses from negative 12 to positive 12, from negative 16i to positive 16i. Then combine like terms. We have this 8 We have this 96, and we have this 12, then this 48i, this minus 64i, and this plus 16i. Negative 8 plus 96 plus 12 is 100, and 48i minus 64i plus 16i is 0i or 0. So therefore, summing this up, the result is 100, which is the right side. That confirms that our answer is correct. Now for the last part, we just show you the same computation, we just changed the sign, and here is the result. And again, we arrive at 100. So we have just verified that the three roots of this cubic polynomial are x equals 5, x equals negative 2 plus 4i, and x equals negative 2 minus 4i. Bye for now.